Hello everyone. A warm welcome to everyone present at the Canadian AI 2021 conference. I am Anubhav Chhabra, a computer science graduate student at the University of Ottawa. And today, I'll be presenting our paper titled HEAL, Heterogeneous Ensemble and Active Learning Framework. So let's take a look at what all will be covered in this presentation. We will start with discussing the problem statement. Then we will be iterating through all the questions that need to be addressed. We will head forward by taking an overview of the HEAL framework and its modules. We will then discuss each module with its architecture in detail. Following it will be a case study on the NSL KDD dataset. And finally, we will be ending with the conclusion. The problem statement. Suppose that currently we are in a data stream environment. That is, we have a continuous flow of unlabeled data with us. In such an environment, we want to build a good model that requires smaller number of instances for training. We want to have a mechanism that helps in selection of critical and useful instances that should be given for human annotation. We would also like to have regular updates to the model, and we would like to make the training as well as the deployment decisions ought to be automated. Now we have some questions to address. Let's look at them one by one. Number 1. Random subsampling of instances for classification tasks could require a lot of instances to get decent performance. How can we move towards selecting quality instances rather than the quantity of instances? If we are able to select quality instances, it would lead us to consume less time, less resources, and less computation power. Number 2. Human annotation can be costly. How can only a subset of data be selected for annotation, which leads to the improvement of the performance of our machine learning model? Human annotation takes time and effort. It would be not a good idea if we give all the unlabeled data for human annotation. It would be better if we figure out a way to only select a subset of data and see if there is an improvement in our machine learning model or not. Number 3. How can this be solved in an environment which deals with a continuous flow of data? That is, we are having a data stream environment and we need to solve the previous two questions. Number 4. Can the model update itself without human interference? Do we really need a human to do the retraining, deployment, and all the management of the model manually? It would be really better if this could be automated. And finally, number 5. How can we come up with a generic and robust system which can address all these questions and can be applied to almost any ML problems with the above interests? The answer to the problem statement and the questions addressed previously is the HEAL framework. HEAL stands for Heterogeneous Ensemble and Active Learning Framework. HEAL consists of two modules, the first one being the Heterogeneous Ensemble module and the second one is the Active Learning module. The basic idea and crux behind HEAL is to make the use of dynamic modeling of heterogeneous ensemble and active learning so as to prepare an end-to-end machine learning pipeline in which the system is capable of retraining as well as deploying the model whenever necessary and beneficial in a data stream environment. We will be now taking an overview of the HEAL framework. The HEAL framework consists of two different modules which are loosely coupled together. The first module is the Heterogeneous Ensemble module that takes care of the modeling of the heterogeneous ensemble. The heterogeneous ensemble is trained using the training data and it uses a voting mechanism to give out predictions when we give it a test instance. These predictions are then passed to the active learning based retraining module. The active learning based retraining module is responsible for the retraining as well as the deployment of the model. In other words, we can say that this module is responsible for updating the model whenever necessary and beneficial. Let's take a deep dive into Heterogeneous Ensemble module now. The Heterogeneous Ensemble module takes the training data set as an input and it outputs a heterogeneous ensemble model. This ensemble model will be used as the initial model in our HEAL framework. We start by the cleaning and pre-processing of our training data. We then check if sampling is required. If it is required, we prompt the user with the possible sampling techniques. We then test and evaluate N models. We then choose k-best models out of these N models, and we use a voting mechanism. This voting mechanism can either be soft voting or hard voting, depending upon the numbers of models that have been selected. The performance of this heterogeneous ensemble model is then improved by coupling it with the active learning retraining module. We will talk about the architecture of the active learning module now. We have used Python, Flask, PostgreSQL, and Apache Airflow to develop the entire HEAL framework from scratch. The icon inside the red circle depicts the serialized heterogeneous ensemble model that we talked about in the previous slide. So here we have a continuous flow of data that is made incident into the Flask server. We also call this Flask server as the prediction API. So this Flask server or prediction API makes the use of this serialized heterogeneous ensemble model to give out live predictions. Once we get the live predictions, we check the confidence score or probability of each prediction, and we compare it to a threshold value. For example, let's say the threshold value to be considered is 0.7. Then we'll be comparing the probability of each prediction with 0.7, which is the threshold. If the value of this prediction probability is less than the threshold, then we append this instance to the domain expert review back table. Or in other words, we simply give this instance to the domain expert or the oracle for review. The domain expert review back table has been made accessible to the human annotator or the oracle. The oracle, using some sort of dashboard, can now annotate the data. Each annotated instance is then dumped into the reviewed instances table. And parallel to this process, we have the Apache Airflow running on a different port, or maybe a different server as well. Apache Airflow uses this annotated data and is responsible for retraining as well as deploying the model again. So once the model is again deployed, the serialized machine learning model in the red circle is replaced by the updated model. Now we will be taking a look at the end-to-end machine learning training and deployment pipeline which has been implemented using Apache Airflow. So we'll be reading this figure from left to right. So we'll start with the left and we'll be moving towards the right. So giving you an overview of the image, the whole workflow is divided into 4 tasks. The first one being check reviewed instances bag, followed by fill training bag, the third one being train model, and the fourth one being deploy model. So in check review instance bag task, what we do is we simply check whether the human annotator has annotated some instances or not. We simply query the database table reviewed instances and it returns us a count. If the count is equal to 0, then we do not proceed forward. If the count is greater than 0 or greater than a particular threshold, then we move forward with the workflow. Coming on to the field training bag, as the name suggests, it picks up the instances from the reviewed instances table and dumps them into the training bag table. Once the instances are dumped into the training bag table, all the instances from the reviewed instances table are deleted. Coming on to the train model task. The train model task is responsible for retraining as well as the evaluation of the newly trained model. So it makes use of the instances from the training bag table and evaluates the model. If in the evaluation we find that the performance of this new trained model is better than the previously deployed model, we proceed ahead with the deploy model task. So let's say that the newly trained model has a better performance than the previously deployed model, then we will be moving forward with the deploy model task and the model will be finally deployed. Or in other words, the heterogeneous ensemble model would be replaced in its folder. Once the deployment has been done, the metadata about the deployment would be pushed to the model deployment history table. Now, we will be discussing a case study on a very popular network intrusion dataset, which is the NSL-KDD dataset. We used a 20% subset for our experimentation purposes, which had a total of 25,000 instances. Out of these 25,000 instances, 4,000 were used as the evaluation set, and rest 21,000 instances were used in the training as well as mimicking the continuous flow of real data. We start by forming the heterogeneous ensemble. Random forest and gradient boosting were the two best chosen models out of the 8. Now we will be seeing active learning in action. Here we are not considering a continuous flow of data. This experiment was carried out just to validate that active learning works and can help us in improving the model's performance. On the left, we see a graph depicting accuracy versus number of random subsampled instances. We can observe a constant trend in accuracy when we move from 1000 instances to 10,000 instances, and the accuracy is around 96%, which is constant throughout. On the right is the bar graph depicting accuracy with respect to number of instances selected with active learning. We trained the initial model on 20 instances and got an accuracy of about 84%, and then selected 5 most critical instances and retrained the model. We kept doing the same process for 11 times to get an accuracy of 96.25% with just 75 instances. On the left, we have 10,000 instances having an accuracy of 96.25%. And on the right, we have just 75 instances and which resulted in an accuracy of 96.25%. So we can conclude that active learning does work. Since we have verified that active learning does work in improving the model's performance, now we will be experimenting with a continuous flow of data. We start by preparing the initial heterogeneous ensemble model, and we use just 100 instances to get an accuracy of 91.575. This model is then plugged into the Heal framework to boost the accuracy, and we reach an accuracy of 97.3% after just 7 iterations of retraining. Here, at each iteration, Heal framework is responsible for the retraining and the deployment of the model. The human interaction is required only for the annotation of the instances which are prompted by the system. Hey, so we are at the conclusion right now. Here, we will summarize the Heal framework altogether. We saw that Heal framework builds heterogeneous ensemble model dynamically based on the task or problem being solved. It considers n models and chooses k best models to form the heterogeneous ensemble. It performs voting mechanism at the time of making predictions. The Heal framework deals with the healing of the machine learning model and its performance over time. We start with a model with a particular accuracy and see it healing or improving over time. The Heal framework requires an oracle to annotate only a subset of data, thus leading to reduction in cost, time, and effort. So we are not giving each and every instance to the oracle to get it annotated. We are doing an intelligent selection of instances over here. These instances are intelligently selected and passed on to the oracle to be annotated. And fourth, Heal framework requires no interference of human for tasks like retraining, deployment, and evaluation of the performance of ML model. All of these decisions are taken automatically by the framework itself, and the humans can monitor the workflow of the pipeline being formed. So basically, we have no interference of human here. Humans can just monitor the workflow for any server or memory outages. If you would like to know more, or if you have any questions, suggestions for our work, you can reach out to us at the following details mentioned on the screen. Thank you so much for listening. Have a great day.